Representing linear functions. A linear equation is an equation whose graph is a line. Alright? So that's why it's called a linear equation. Linear equations are also functions. Okay? So they will pass the vertical line test. I want you to write down y equals 7x. Alright? And then I want you to write the table. In your homework, it will only be it'll only have x, y equals 7x, and y. Okay, I've added this section to it. Okay, you'll have to make these tables in your homework. Alright, add x and y with it. Okay. The homeworks will say find 4 solutions. So what we do is we plug in numbers into our independent variable, which is x. Remember, our independent variables are chosen. That means you choose them. Alright? Now in your homework, I think it already picks them for you. I pick some very easy numbers. Okay? So just pick 4 numbers if they make you pick them. Or, yeah, if they make them pick your own, pick 4 numbers to put in for x. Okay? So what we do is we give an input, our x is input, we find our output, which is our y coordinate. So I plug in -1 for x. Then I do the operation. 7 times -1 is -7. My ordered pair is my x coordinate that I picked and my y coordinate, which I found. I do that 4 times. So I put in 0 for x. 0 times 7 is 0. I plug in 1 for x. 7 times 1 is 7. So my coordinate is 1, 7. And I plug in 2 for x. My coordinate is 2, 14. So sometimes they'll give you a table like this. They'll say solve for it, or copy and complete the table, and then find 4 solutions, write them as ordered pairs, exactly like what we did. All right. It also might give you a graph and wants you to put these on a graph. Okay, so plot each point. All right, and then connect the dots. All right, so write y equals 3x minus 1, and let's fill out another table. All right, so the equation is y equals 3x minus 1. Again, we have to find 4 solutions and write them as ordered pairs. So I'm going to pick some numbers. -3, -1, 0, and let's go 1. So 3 times -3, then subtract 1. 3 times -3 is -9. -9 minus 1 is -10. So my ordered pair is -3, -10. You guys go ahead and fill the rest of the table out on your own. So 3 times -1 minus 1. What is 3 times -1? Negative. Well, 3, and then minus 1 is what? You just said it. -4, right? So I put 0 in there. 0 times 3 is 0. 0 minus 1 is -1. And we put 1 in there. 3 times 1 is 3, minus 1 is 2. That is how you would copy and complete this table. Okay, go ahead and write these 2 definitions down. This just says that the x-coordinate of the point where the graph crosses the x-axis is the y-intercept. So if this is a graph, okay, and this is my x-axis, wherever it crosses, like if the line crosses right here, this is what we call my x-intercept. Okay? The y-coordinate of the point at which the graph crosses the y-axis is the y-intercept. So this point where it crosses the y-axis is called the y-intercept. So if we have a graph here, okay, this is my y-intercept, and this point right here is my x-intercept. But I want you guys to notice something about this graph. For x-intercepts, okay, for this x-intercept right here, okay, what's its ordered pair? 0, 3 or 3, 0? 3, 0. Okay, what if my x-intercept was right here? What would this be? Negative 5, 0. What if it was right here? What would the ordered pair be? Does anyone see a pattern here? What is it? The y is always 0. So for my x-intercept, y is always 0. Okay? What about my y-intercept? What's the ordered pair of that y-intercept up there? What's the ordered pair? 0, 4. What about right here? What if it was right here? What about right here? Is there a pattern here? What is common about every y-intercept? X is always going to be 0. Right? So we can use that when doing a problem like this. So go ahead and write graph negative 2x plus y equals 4. And then in your graph that I gave you, we're going to graph this. We're going to do it by graphing the x and y intercepts. Okay, so now, like I said, we can graph this using x and y intercepts. We can also, there's also another way, and that's using the table like we've been doing on the problems, picking x's, finding our y's. Okay, but this one's a little bit harder to do. Okay, doing that, but we could find 4 ordered pairs and then graph them that way, or we can just do the x and y intercepts, and I think that's much easier. So I need to find my x-intercept. Someone tell me how I'm going to find the x-intercept. What did I say is common about every x-intercept? What, Braden? Well, the y is always going to be 0. So what I just do is I just plug 0 in for y. What's left? Negative 2x equals 4, right? So I divide by negative 2. My x-intercept is at negative 2. Is 4 divided by negative 2 is negative 2. That's my x-intercept. Okay, now we need to find the y-intercept. What did I say is common about every y-intercept? X is 0, right? So what I do is I plug a 0 here. All right. So that leaves me with this, y equals 4. So what's my y-intercept? 4. Now that I have 2 dots, I can graph that, which all I do is draw a line through them. This line matches the graph, the equation right here, negative 2x plus y equals 4. Alright, now if this is confusing you, you could do this. You could do a table with x and y. Okay, pick a couple points. I'm going to pick 0, and I'm going to pick negative 2. If I plug 0 in for x, I got 4 for y, right? If I put negative 2 in there, negative 2 times negative 2 is 4. Well, so y, my y would be 0. Yeah, if I put in negative 2 for x. Because that would be negative 2 times negative 2, which is 4. So 4 plus y equals 0. So I subtract 4 both sides, y equals 0. So I could pick another point, right, and it would be here. If I pick 2, it would be right about here. So you could do it. You could do a table, put 4 ordered pairs, and then graph them that way. Or you can just find the x and y intercepts. plugging 0 in for y to find your x, plugging in 0 for x to find your y. Okay, so let's do it. Let's do this. Y equals x minus 4. Now again, we can do it two ways. Do a table with x and y. Alright, I'm going to do it both ways, just to show you how it works. So, -1 for x, -1 minus 4 is -5. Right? Zero in there for x, that means y equals -4. You put 1 in for x, you get -3. Put 2 in for x, you get -2. Everybody see how I did that? Yeah. Okay? Could I draw a line? Yeah. Yeah. Okay, so that's one way of graphing it. Here's the other way. I can find my x-intercept, and I can find my y-intercept. My x-intercept, I plug in 0 for y. So I got 0 equals x minus 4. So what does x have to be to make this true? 0 equals x minus 4. What does x have to be? 4, okay? Because if I add 4 to both sides, what does x equal? 4. Well, what's my y-intercept? I plug in 0 for x. What's my y-intercept? What's 0 minus 4? -4. Well, look, I've already graphed my y-intercept. And look, I've already graphed my x-intercept. So either way, does it matter which way you use? No. Here's your assignment.